So we're going to begin with our warm-up for stuff that we covered yesterday. Let's take a look at the first example here in our warm-up. We want to find two angles in between 0 and 360 degrees satisfying this equation here. Now, the first step is always to find the reference angle, which I will again denote by theta, as you recall from yesterday. That is the sine inverse of negative 0.848, which on your calculator will yield negative 58 degrees. Clearly 58 degrees negative is not between 0 and 360, so we have to read that angle. I'll just draw a quick diagram from 0 counterclockwise. What's that going to be? So negative 58 is over here. That means my other angle is going to be 302 degrees, which is just 360 minus 58 degrees. Now the other angle, because sine is negative, I know that sine, according to the CAS rule, is going to be negative in quadrant 3 as well, so I'm going to draw a 58 degree angle here. That's my 58 degrees. And I know from 0 to that arm there, I'm going to get 238 degrees. So those are my two angles between 0 and 360 for the first one. Now for the second one, I'm looking at cosine of the angle. Again, my reference angle alpha is going to be given by cos inverse of 0.8192, close bracket, which on my calculator gives 35 degrees. What does that look like in the plane? Well, 35 is roughly down here, and I know that cosine is positive also in quadrant 4, so I'll draw a 35 degree angle there, which means, I'll do this in red, my angle goes from 0 counterclockwise all the way to 325. So that's my second angle, 325 degrees. Again, if you want to check that independently, what you can do is do cosine of 325, and you'll end up with the same number as before. Finally, for tan theta, I'm going to again take my reference angle alpha to be the tan inverse of negative 4.3315, close bracket, gives me 77 degrees. What does that look like? Well, it's roughly going to be over here. I know tangent is also positive in quadrant 4, so my second angle will go from here all the way to this terminal arm, which is going to read, let me see here, 283 degrees. That is arrived at by subtracting 77 from 360, which is one full complete revolution. So our two angles are 77 degrees and 283 degrees. There you have your warm-up. Now we'll get started with the lesson itself. So let's get started with the lesson. Okay, the angles here that we're talking about, okay, for today are specifically, and you'll see why these angles have been stated, are 30 degrees, 45 degrees, and 60 degrees. So I want to begin by just exploring the triangles that we have in front of us. So in triangle number 1, this is an isosceles triangle. You'll notice that there's two sides that are equal. And for sake of argument, and I could label them any value, I can give them any value I want, but I'm going to say that they are 1 unit in length, 1 unit in length, and therefore my hypotenuse h by Pythagorean theorem is going to be 1 squared plus 1 squared, which gives me a value of square root of 2. So I can rewrite h as root 2, which I will do right here, square root of 2. And because the base angle is 45, we know that the top angle here is also 45 degrees as well. So we say that these sides are in a 1 to 1 to root 2 ratio. Okay? And if you actually look at the angle and its opposite side, we know that 45 is going to be 1, 1, and 90 is going to be root 2. Again, this is all just based on the diagram I have in front of me. Now for the second one, the triangle I'm looking at is 30 degrees, 90 degrees down here, and obviously the angle remaining by the sum of triangles, interior angles in a triangle add up to 180, is going to be 60 degrees. So I have 60 degrees in here. Now, over to the side, I want you to focus your attention for a moment. Let me take away some work I've done beforehand so that we can arrive at it together. What I've done is I've drawn an equilateral triangle. That means all the internal angles must be 60 degrees, and I've just, well, I have a purpose in mind to come ahead, but what I've done is I've labeled all the angles and sides, so the angles are all 60, all the sides are all 2 units in length. So bear with me for a sec. Here is 2, and if I drop a perpendicular from, say, the top angle down here, okay, I end up with 30 degrees on the inside, 90 degrees at the perpendicular, and my original 60 down here. In addition to that, dropping the perpendicular bisects the base into 2. So if the entire distance is 2, half of it is going to be 1, obviously. So right now I have 2 side lengths. I have the 2 here, I have the 1 here. I now want to find the third side. And I do that using Pythagorean theorem. So I'll call this x for now. And I know that 1 squared plus x squared equals 2 squared. Or I can rewrite that as x squared equals 4 minus 1. Or I can write it as x equals root 3, which ends up being our third side. So I'll put that in here right now. I have square root of 3. And here's the thing. Let me show you something really neat right now. I'm going to take this triangle. I'm going to cut it out here. I'm going to tilt it and superimpose it on the triangle I have right there. Okay? Let's just put that down. What do you notice here? Okay, the opposite side here is 1. My hypotenuse here is 2. My base is here is root 3. So we say that this triangle is in a root 3, 1, 2 ratio. The side opposite 30 is 1. The side opposite 60 up here is root 3. And the side opposite 90 is 2. Let's see how we can now use these facts to calculate exact values for sine, cosine, and tangent in the next few examples. Looking at our first example now, we want to find the exact value of sine 30, cosine 30, tan 30. Now from before, we know that the triangle that has 30 degrees in it is this one here, the 30, 60, 90 triangle. Now the way I do these type of problems is very visual, which should be helpful to you in solving them. What I do is, once I've determined the angle that I'm looking at, I draw the corresponding triangle. So I know because I'm using 30 degrees, I'm going to be using the 30, 60, 90 triangle, which is this one here. I label the sides accordingly as we did above, and I superimpose that triangle onto my Cartesian plane. And there you have it. Let me just move it into place a bit better. There we go. So the way you read this now is, well, along the x-axis, I have my root 3 positive. Along the y-axis, I have positive 1. And my hypotenuse is always going to be positive. In this case is 2. So to solve for sine, cosine, and tangent, it's very simple. I know that sine of 30 degrees is opposite over hypotenuse. In this case, opposite of 30 is 1, and the hypotenuse is 2. So I have 1 over 2. Cosine of 30 degrees is equal to adjacent over hypotenuse. In this case, it's going to be root 3 over 2. And tangent of 30 degrees is going to be adjacent, the root 3, sorry, the opposite. In this case, it's 1 over root 3. Opposite over adjacent gives you my tan value. And that's it. You've superimposed the triangle into the plane. You just read off the angles as they appear. In example 2 now, we're looking to find the exact values of sine of 60 and cosine of 45. So let's take the first one, sine of 60. You'll notice that over to the side of my Cartesian plane, I have the 60, 30, 90 triangle. Because 60 is the angle I want to use, that is the only angle I actually labeled in my triangle, I take that triangle, drag it onto my plane, or draw it directly on in your case, and I just read them off. So I know sine of 60, well, sine is opposite, which in this case is root 3, over hypotenuse, which is 2. So sine of 60 degrees is just going to be root 3 over 2. Now for cosine, we're finally going to get to use our other triangle. I drew my 45, 45, 90 triangle. I take that, because 45 is the angle I'm looking at, I bring it onto my plane, drop it in, see if I can position it better, there we go, drop it in, and, well, just recall the definition of cosine of 45, which is adjacent over hypotenuse, therefore cosine of 45 degrees is going to be 1 over root 2. So in example number 3, we're looking to find the exact value of sine of 120 and cosine of 120. Now, in your handout, you have this 2 pi over 3 business. I cross it out. That has to deal with radian measure, which we used to address in this course, but not anymore. Next year, you will in grade 12 advanced functions. So for now, just replace that 2 pi over 3 with cosine of 120. So we're looking at our first one. 120, well, we know that it produces a reference angle of 60 degrees. How do I know that? Well, in my plane, if I draw 120 degrees, it goes from here to here. I get 120. The reference angle it makes with the x-axis is this one here, and that is 60 degrees. As well, we know that is going to be in quadrant. So that's 60 degrees here in quadrant number 2. So my reference angle is 60. That means I'm going to be using my 60, 30, 90 triangle. I will take that triangle, superimpose it into my plane. You know what, before I do that, let me just erase this angle because it's not going to match up exactly. I take this triangle, superimpose it into my plane, and just to be consistent, I will put back in the 120 degrees, which is here, And now we have to kind of alter our triangle a little bit in terms of the signs, okay? What do I mean by that? Well, we're looking at the negative x-axis here. That means that 1 is going to be a negative value. Okay, the root 3, because it's in the positive y-axis, it remains the same. And the hypotenuse, the 2, will always be positive, regardless of what quadrant we're in. So with that in mind, sine of 120 is just like taking sine of 60. Okay, so we look at opposite, which is root 3, hypotenuse, which is 2, and we can say that sine of 120 is equal to root 3 over 2. Now for cosine, it's slightly different because cosine uses the adjacent side of negative 1 and the hypotenuse of 2. So cosine in this case of 120, the exact value is going to be negative 1 over 2. We're looking at example number 4 now, and we want to find the exact values of tan of 135 and cosine of 210. So 135 degrees, if I look at my plane, is going to lie somewhere, I'd say right about here. So it's 90 plus 45 degrees, so I'm looking at that angle there. Now what I've done is, here at the side, I've drawn my 45, 45, 90 triangle. What I'm going to do is, again, superimpose it onto my plane. Here's what it looks like. Take that. Let me just try that again. So I'm going to take this part, bring it over here, just plant it in properly. And this way we can now label our sides. So because 1 is in the negative for the x part, we have negative 1. The y is positive and the hypotenuse is positive as well. This angle here is 135 degrees. My reference angle is 45. Tangent of 45 in this case is opposite over adjacent, and I get tan of 135 equals negative 1, or 1 over negative 1, which is just negative 1. Now for cosine of 210, well, 210 degrees is going to lie 180 plus 30. It's going to be somewhere down here. Okay? So let me just clear up my picture a bit, because what I'm going to be doing is I'll bring in to the picture my 30, 60, 90 triangle. This way I can see my angle of 210 degrees. Just straighten that out. Put it there. There we go. That's okay. Here I can see my angle of 210 degrees. Let me just get rid of all this. And it goes from here all the way around. And there is my 210 degrees. So in this case, I have a negative y value, so I'm going to put negative 1. My root 3 is going to be negative as well. And cosine of that, which is cosine of 30 in here, is going to be root 3 negative over 2. So I get cos of 210 equals negative root 3 over 2. So here are some that I want you to try on your own, and once you've done that, you can watch this video to take up your solutions. So for the first one, sine of 210, 210 minus 180 gives us 30. So that means I'm going to be using my 30, 60, 90 triangle. I'm going to take that triangle, superimpose it once again into my Cartesian plane here. And I know that 210 goes from 0 all the way around here. So that is 210 degrees. The root 3 is negative, the 1 is negative, and sine of 210 is going to be opposite, which is root negative 1 over hypotenuse. I get negative 1 over 2. I'll just move that down here. Now for cos of 240, 240 lies in my third quadrant, and it's going to be 180 plus 60. So in this case, I'm going to be taking this triangle here. Let me cut it out. And I'm going to turn it around so that I have the 60 degree right there. Just put it in exactly right there. So this angle here is going to be 60 degrees. And cos of 240 goes from 0 to 240. So this is 240. And again, based on my values and where I am in the plane, I know that cosine is adjacent over hypotenuse. So therefore, cos of 240 degrees is going to be negative 1 over 2. And I'll just move that over here. Finally, 225, well, that's just 180 plus 45. So I'm obviously going to use my 45, 45, 90 triangle. Take it here, turn it around. So I got my 45 degree angle there. Just place it properly on my axis. And these values here are going to be negative 1, and the root 2 stays the same. So 225 goes from here to here, and tan of that is opposite over adjacent, which is just 1. And that equals 1. So again, hopefully you got these ones right, but do the work first and compare afterwards. Here in example 5, we're again looking at the sine, cosine, and tangent of some larger angles. In this case, they all lie in quadrant number 4. Make sure you replace the radians over here, right here, and right here with the corresponding degrees. Just ignore the pi's and all those fractions. So the first one is sine of 300. So 300 we know is 30 degrees past 270, or we can think of it as 60 degrees below 360. So in this case, I'm going to use this triangle. I'm going to take it over here, rotate it so that it lies on the positive x-axis and the negative y part. Let me just relabel the sides so we can see what they look like. So in this case, I have negative root 3, and I have positive 1. Now we know sine of 300, well, that goes from here to here, is going to be the same as the sine of the reference angle, which is negative root 3 over 2. So the answer to this one is equal to negative root 3 over 2. For cosine of 315, well, we know 315 is 45 degrees before or below the x-axis. So that means I'll be taking this triangle, reorienting it so that it flips upside down, and put it in here. Again, let me just label all the sides accordingly. I get negative 1, 1, and root 2. And this 45 degrees, I'll just turn it upside down so that it faces right side up. And I'm looking at cosine. So cosine of 315, which is this angle, is the same as the cos of the reference, which is 45, and cos of 45 is 1 over root 2, adjacent over hypotenuse. For the third one, I'm looking 10 of 330. So in this case, I'm looking at 30 degrees less than 360. So I'll take this triangle here, place it in my plane, zoom in. I know that this side is going to be negative because it's below the x-axis. And by definition, 10 of 330, 330 being this angle, 30 being the reference angle, is going to be opposite over adjacent, which is just negative 1 over root 3. And there you have it, some exact values for angles between 270 and 360. Further on, I mean, you don't have to memorize these because, I mean, really, you can punch these numbers into your calculator at any time, but you pretty much know what these are. Let's move on to example 6 next. Here in example 6, we are given the exact value of cos theta, and we have to find theta. So we know that we're given a negative value, which means that theta is going to be in quadrants, and this is according to the cast rule, is going to be in quadrants 2 and 3. So theta is going to be somewhere over here, so from there to there, and somewhere here, from here to here. Let's just focus on the first one, because once we have that, we can get the second angle easily. So negative root 3 over 2. Very familiar to our 60, 30, 90 triangle. This is 60, this is 30, this is root 3, this is 1, this is 2. So in terms of how that looks like in my plane, well, let me actually draw this triangle a little bit better and superimpose it. Flat side, and I'm looking at root 3, 2, oh, that's 1, and 2 over here. That's 60 degrees. So the way I like to think about this, I know that one of my sides, I have to have a negative root 3 in there. So I'm going to take my triangle and rotate it so that I have my root 3 being negative. There you have it. I can have my root 3 here on the negative x-axis. The 2 I'll just put the right way, and the 1 as well, I'll just put it up. So what angles does this correspond to? I go from 0 all the way to, well, if this is 30 here, I'm left with 150 as my main angle, which means that over in here, my quadrant number 3, the angle will be from 0 to 180 plus 30, which is 210 degrees. So those are my values for theta, such that cos of those angles gives me a root 3 over 2, negative that is. In example number 7, I'm looking at the tan of negative 1 over root 3. And I know that tan is negative in quadrants number 2 and quadrant number 4 as well. So negative 1 root 3, that reminds you of the 30, 60, 90 triangle. So let me draw that over here. So there's my 30, there's my 60, and my 90. know that I'm going to be in quadrant number 2. Let's take 2 first. And I know that my 1 value is going to be negative 1. So 1 is over here, and I know it's going to be negative. So here's what I do. I take my triangle, bring it into my plane. This way, I have negative 1, zoom in here. Root 3 is here on the side, and here is 2. The angle corresponding is 60 degrees, the reference angle, which means that the main angle is 120 degrees. So my first angle theta is going to be 120. In quadrant number 4, on the other hand, let me erase this stuff here. I take the same triangle. I'm going to rotate it. Let's see here. Rotate it around so that this way I have root 3 here at the side, which is my opposite. And it's negative root 3 because it's in the negative y region. I have a 1 here. And this is my angle of 60 degrees, which means my main angle is going to be 300 degrees. So my other value of theta is 300 degrees. Finally, in our last example, we're looking to find some values of theta such that sine theta equals root 3 over 2. I know sine is positive in quadrants number 1 here as well as quadrant 2. So root 3 over 2 should remind you of our 30, 60, 90 triangle, which I'll draw here. I have my root 3, 1, and 2. I'm going to take this triangle, bring it into my plane, superimpose it onto my graph. There we go. And root 3 over 2, well, that's just opposite over hypotenuse, which is here. Therefore, my angle is 60 degrees for my first one in quadrant 1. And in quadrant number 2, well, I'm still going to be positive, except that in this case, let me just take my triangle, and in this case I'll just write it in. I got 60 over here, negative 1, root 3 positive 2 here. Sine is opposite over hypotenuse. The reference angle is 60, which means my main angle is 120 degrees, and that gives me my second value. You have plenty of practice for this lesson. I suggest you get started as soon as possible.